Hello dear students, example number 7. So we have another question about the total capacitance or equivalent capacitance. So we have on the right side we have the figure. This figure shows that we have two capacitors C1 and C2, and they are connected to the 24 volt battery. And first we charge these capacitors C1 and C2. So when the total charge develop on these two capacitors C1 and C2, the values of capacitance is also given. C1 is 2.2 microfarad and C2 is 1.2 microfarad. Okay. So this is the initial configuration. So when the charge is full, after charging, when the charge is completed on these two capacitors, so we disconnect this battery. And we attach these two capacitors directly with the plates. So positive plate is connected with the negative one and negative plate is connected with the positive one, so that the charge redistribute themselves, because we know that these so that the because we know that the different potentials develop on C1 C2, because we know that the V1 potential developed on the capacitor C1 is different and potential developed on the capacitor V2 is different, so the charge redistribute in a such a way that the final charge is Q1 and Q2 that is stored in these combinations, so that when the potential is balanced, V1 V2 is equal to V, so that now the charge stops flowing between the capacitors. Okay, so we need to find the how much charge flows. I think so we need to the find the charge on each capacitor and the potential across after the equilibrium is established. Okay, so in order to solve this equation, so first we must find the charge Q1 and Q2 that is stored after charging. Okay, so Q1 is equal to C1V. We use this formula, Q1 is equal to C1V. So C1 capacitance is given in the question, 2.2 microfarad, and potential is 24 volt. So that capacitor 1 stores 52.8 microcoulomb. So Q1 is 52.8 microcoulomb and Q2 stores 28.8 microcoulomb. By using this formula, Q2 is equal to C2 and V. As we know that C2 and V, all the things are given. Okay, now after that, when these capacitors are connected across their ends, so that the discharging occurs, so that the charge try to equalize, so that now the potential is developed in this case, so that the potential formula for a new potential equation is Q1 is equal to C1 V dash. So V dash is the new potential that is developed after the equilibrium is established. So but we don't know the value of Q1, Q2 and the V new charge, mean how much charge flows from C1 to C2 or C2 to C1, how much charge is redistribute themselves. So we don't know value of the charge Q1, Q2 and the V dash, three things. But we know that the total charge Q1 plus Q2 must be equal to the difference between Q1 and Q2. Mean if Q1 charge flows towards the Q2, so that it means there must be the difference between the charges, because we know that capacitor Q1 the capacitor C1 has more ability. We also know the capacitor C1 has more ability than C2. It means C1, there must be the charge on C1, greater charge flows on the C1, I think so. Okay, so so Q1 is equal to C1V and Q2 is equal to C2V, new formula for charging Q1, Q2, so that the total charge on the upper plates in those two figures must be the same. So Q1 plus Q2 is equal to Q1 minus Q2 initially. So Q1 plus Q2 is equal to Q1 minus Q2. So Q1 is, as we know that Q1 is given in the question, we find Q1 52.8 microcoulomb minus 28.8 microcoulomb, that will give us 24.0 microcoulomb. So this is the value of Q1 plus Q2. Okay, now we use these three equations, equation number 1, equation number 2, equation number 3. This is equation number 3. First we add these equation 1 and 2, add 1 and 2. So when we add these two, so Q1 plus Q2 is equal to C1 V dash plus C2 V dash. So we are left with the C1 plus C2 into V dash, and Q1 plus Q2 is already know the Q1 plus Q2 is 24.0 microcoulomb. So V dash is equal to 24 over C1 plus C2, and C1 plus C2 is given in the question, that is equal to C1 is I think 2.2, C1 is 2.2 and 1.2, 2.2 and 1.2, 2.2 microfarad, sorry 1 minute, 24 divided by 24 divided by C1 at 2.2 microfarad plus 1.2 microfarad, that will gives us, that is microcoulomb, that will gives us 24 microcoulomb divided by, that will give us 3.4 microfarad. So V dash, so potential V dash is equal to, now we find the potential V dash, that is equal to 7.06, that is 7.1 volt. So the new potential is 7.1, because when the charges move, so the new potential is 7.1. So if we know the new potential, so Q1 is equal to C1 V dash. So C1 is ability is 2.2 microfarad and potential V is 7, new potential is 7.1 volt. Now we get 16 microcoulomb, so round off to 16. Q2 is equal to C2 V dash, so C2 is 1.2 microfarad, and we multiply the potential V dash, that is 7.1 volt, that gives us 8.5 microcoulomb. So this is the new charges that, so initially we can say that Q1 is 52, but finally Q1 is 16, and initially the Q2 is 28.8, but finally the Q2 is 8.5 microcoulomb. Okay, thank you.